Mount Spurr, a massive volcano in Alaska, is showing signs of unrest, and experts warn that an eruption could be imminent. With increased seismic activity and other warning signs, the possibility of an eruption is becoming more real. In this hypothetical scenario, we'll explore what would happen if Mount Spurr erupts tomorrow, how it would impact Alaska, disrupt daily life, and reshape the landscape in an instant. If Mount Spurr in Alaska erupts tomorrow, the first signs would likely be noticeable hours or even days before the main event. Scientists at the Alaska Volcano Observatory would detect an increase in seismic activity, small earthquakes beneath the volcano, signaling that magma was rising toward the surface. These tremors would become more frequent and intense, with some strong enough to be felt in nearby areas. As pressure built up beneath the mountain, the ground might begin to bulge slightly, a sign of magma forcing its way upward. In addition to seismic activity, changes in the volcano's summit crater would likely occur. A small lake that formed at the peak in the summer of 2024 might begin to heat up, steam rising as gases escaped from the magma below. Fumaroles, venting openings in the earth, could release more sulfur dioxide and other volcanic gases, creating a strong rotten egg smell in the air. These warning signs would trigger emergency alerts warning residents of south-central Alaska, especially in Anchorage, about a possible eruption. The region would quickly move into a state of heightened alert. The National Weather Service would begin monitoring wind patterns to predict where volcanic ash might fall, while emergency agencies would issue advisories on how to prepare. South Central Alaska residents would be urged to gather emergency supplies, including masks to protect against airborne ash, extra food and water, and plastic coverings to keep ash out of homes and vehicles. Airlines operating at Ted Stevens Anchorage International Airport would start rerouting flights to avoid potential ash clouds, just as they did during past eruptions. The uncertainty surrounding when and how an eruption might unfold would create tension. Volcanic eruptions are notoriously difficult to predict with exact timing, and while Mount Spurr has erupted before, each event is different. The last major eruptions in 1992 came in 3 separate bursts over 3 months, with little warning between them. If tomorrow's eruption follows a similar pattern, the first explosion could be the beginning of a prolonged period of activity. As the day progresses, Mount Spurr might begin releasing small ash bursts, an early indication that magma was nearing the surface. These bursts wouldn't be catastrophic, but would send fine, volcanic dust into the air, carried by the wind toward Anchorage and other nearby areas. Social media and news reports would be flooded with images of the volcano, spewing dark smoke into the sky. Some people might rush to stock up on supplies, while others would wait anxiously for official updates. By nightfall, the eruption could be fully underway. The sky over the Tordrillo Mountains might glow with an eerie orange light as molten rock burst from the summit crater. A towering column of ash, possibly tens of thousands of feet high, could spread outward, carried by the jet stream. The people of Anchorage, just 75 miles away, would soon experience the effects as volcanic ash began to settle over the city, covering streets, cars, and rooftops in a fine, sand-like layer. Tomorrow's hypothetical eruption would be unlike anything most Alaskans have seen in decades. But as the first signs of disaster appeared, the real question would be, how bad could it get? As the eruption of Mount Spurr escalates, the effects would begin spreading far beyond the immediate area. With a towering ash cloud now rising into the atmosphere, the biggest concern would be its impact on air travel. Volcanic ash is not like ordinary smoke. It's made of tiny, jagged rock particles that can severely damage aircraft engines. Pilots flying in the region would receive urgent warnings to change course, and within hours, Ted Stevens Anchorage International Airport would be forced to suspend operations. Other smaller airports in south central Alaska, including those in Kenai and Homer, would likely follow suit. The last time Mount Spurr erupted in 1992, the ash caused major flight disruptions, and this time the effects could be even more widespread depending on wind patterns. Inside Anchorage, daily life would quickly be upended. The ashfall would continue coating roads, buildings, and vehicles, turning the city into a gray, dust-covered landscape. Even a thin layer of volcanic ash can be dangerous. It clogs air filters in cars, damages electrical equipment, and makes breathing difficult, especially for those with respiratory conditions. The city's emergency services would begin distributing N95 masks, urging residents to stay indoors as much as possible. The weight of the ash could even threaten rooftops if the eruption continued for an extended period, leading to potential structural damage. Further west, closer to Mount Spurr itself, the situation would be even more dangerous. While Anchorage and other populated areas would mostly face ashfall, the remote terrain surrounding the volcano could experience far deadlier hazards. Pyroclastic flows, fast-moving waves of scorching gas, ash, and rock would race down the mountain slopes at speeds over 100 miles per hour, obliterating anything in their path. These flows are among the most lethal aspects of a volcanic eruption, capable of burying entire landscapes in superheated debris. In addition to pyroclastic flows, another major threat would be lahars, massive mud flows created when volcanic heat melts the mountain's glaciers. Mount Spurr is heavily covered in ice, and as the eruption intensifies, that ice would rapidly melt, mixing with ash and rock to form thick, cement-like rivers of debris. These lahars would rush down nearby valleys, potentially damming the Chukachotna River and backing up water into Chukachemna Lake. If enough pressure built up, the resulting flood could send a surge of water downstream, threatening remote areas and eventually reaching Cook Inlet. Authorities would be closely monitoring river levels, knowing that past eruptions of other Alaskan volcanoes have triggered catastrophic flooding. Warnings would be sent out to anyone in the region, though in such a sparsely populated area, there would be little time to react. For those living in remote cabins or working at fishing camps near the inlet, the combination of ashfall, mud flows, and potential flooding would create a life-threatening situation. Despite the chaos unfolding on the ground, the full impact of the eruption wouldn't be immediately known. Volcanic eruptions can last for days, weeks, or even months, meaning this could be just the beginning. Scientists at the Alaska Volcano Observatory would be analyzing every piece of data they could gather, trying to determine whether this was a short-lived explosion or the start of a prolonged period of activity. The last major eruptions in 1992 occurred 3 times over 3 months. If Mount Spurr followed the same pattern, Alaska might be facing long-term consequences. As the eruption of Mount Spurr continues, the long-term effects on Alaska's environment and infrastructure would begin to take shape. The immediate chaos of the ashfall, flight disruptions, and lahars would give way to new challenges, ones that could last for months or even years. The air quality across south-central Alaska would remain dangerously poor, with fine volcanic ash lingering in the atmosphere. This ash, made of tiny glass-like particles, would be hazardous to breathe, especially for children, the elderly, and those with respiratory issues. Hospitals in Anchorage and surrounding towns would likely see an increase in patients experiencing breathing difficulties, eye irritation, and other health problems linked to airborne ash. And beyond human health, the impact on Alaska's wildlife and ecosystems would also become a growing concern. The ash blanketing the landscape would seep into rivers, lakes, and streams, affecting water quality and potentially harming fish populations. Salmon, a vital part of Alaska's fishing industry and ecosystem, could struggle to survive if their spawning grounds became clogged with volcanic debris. In past eruptions, volcanic ash has led to mass die-offs of fish and other aquatic life due to changes in water chemistry and reduced oxygen levels. This disruption to the food chain could have lasting consequences for the many species that rely on these waters, from bears and eagles to seals and whales in Cook Inlet. In the mountainous regions closer to the volcano, the weight of the accumulating ash could trigger landslides, sending massive amounts of rock and debris crashing down valleys and into rivers. These landslides, combined with ongoing lahars, could alter the landscape permanently, reshaping river channels and destroying habitats. The once pristine wilderness of the Tordrillo Mountains could be left scarred for decades, its slopes buried under layers of hardened volcanic deposits. The economic toll of the eruption would also become clearer. With Ted Stevens Anchorage International Airport shut down for an extended period, cargo shipments would be severely disrupted. Anchorage serves as a critical hub for international air freight, particularly between Asia and North America. Any prolonged closure would lead to significant financial losses for airlines and businesses that depend on the flow of goods. Stores in Anchorage and other cities could start experiencing shortages of certain imported products, while the state's fishing and tourism industries would suffer major setbacks. The summer tourism season, which brings thousands of visitors to Alaska's national parks and remote lodges, could be thrown into uncertainty if the eruption continued into the warmer months. Efforts to clean up the ash would be a massive undertaking. Crews would work around the clock to clear roads, highways, and airport runways, but the fine, powdery nature of volcanic ash would make it a persistent problem. Even after visible layers were removed, Strong winds could stir up settled ash for months, making it feel like the eruption never truly ended. Vehicles and machinery exposed to the ash would require constant maintenance, as the tiny particles can grind away at engines, clog filters, and corrode metal surfaces. With the volcano still active, geologists would be working tirelessly to determine whether the worst was over or if more eruptions were on the way. In past events, Mount Spurr's eruptions occurred in multiple stages, sometimes months apart. If seismic activity beneath the volcano remained high, it could signal additional explosions to come. The uncertainty would weigh heavily on residents, who would have to decide whether to stay put or temporarily relocate until the danger passed. As Alaska braced for what could be an extended volcanic crisis, one thing would be certain: Mount Spurr's eruption was not just a single event, it was a disaster with lasting consequences. The question now was how long those consequences would continue. In the weeks and months following Mount Spurr's eruption, Alaska would begin the long process of recovery. While the immediate danger from ashfall, lahars, and pyroclastic flows would have passed, the long-term challenges of rebuilding and adapting to the new landscape would become the focus. The region around the volcano, once a popular destination for backcountry hikers and snowmobilers, would remain unstable for years. Large sections of land would be permanently altered, with deep ash deposits, collapsed riverbanks, and newly formed volcanic features making navigation dangerous. Scientists would continue monitoring the volcano for any signs of renewed activity, as secondary eruptions or aftershocks could still pose a risk. One of the biggest hurdles in the aftermath would be the impact on infrastructure. Even after roads and airports were cleared of ash, lingering particles in the air would cause ongoing issues. Fine volcanic ash is notorious for infiltrating ventilation systems, damaging electronics, and wearing down mechanical parts. Homes, businesses, and public buildings in Anchorage and beyond would require extensive cleaning and repairs, with some structures possibly deemed unsafe due to ash accumulation on rooftops. Power outages would also remain a concern, as ash buildup on electrical equipment could lead to failures in the grid. Water contamination would be another major issue. With ash washing into rivers, lakes, and reservoirs, water treatment facilities would need to work around the clock to ensure a safe supply for residents. In more remote areas where people rely on well water, many would find their sources compromised, forcing them to rely on bottled water or government-provided resources. Farmers and ranchers in south central Alaska would also face difficulties, as volcanic ash can severely impact soil quality, making it harder to grow crops or maintain grazing lands. The economic ripple effects of the eruption would continue to be felt for months, if not years. Alaska's fishing industry, already dealing with declining salmon populations, would struggle as volcanic debris disrupted marine ecosystems. With the tourism sector taking a hit, businesses that rely on visitors, hotels, tour operators, and local shops would face financial hardships. Insurance claims from property damage, business losses, and vehicle repairs would surge, creating delays and complications for residents trying to rebuild. Internationally, Mount Spurr's eruption would serve as a reminder of the ever-present threat of volcanoes, especially those in the Pacific Ring of Fire. Scientists around the world would analyze data from the event, using it to improve monitoring systems and refine eruption forecasting models. The lessons learned from Mount Spurr could help other regions better prepare for similar disasters in the future. Despite the challenges, Alaska is no stranger to extreme conditions. Its residents have endured earthquakes, wildfires, and past volcanic eruptions, always finding ways to adapt and move forward. With time, Anchorage and the surrounding communities would recover. Though reminders of the eruption, layers of ash in the soil, altered landscapes, and the occasional aftershock would remain for years to come. The event would go down in history as another chapter in Alaska's long relationship with its powerful and unpredictable natural forces. While the eruption of Mount Spurr may eventually fade from the headlines, it would leave a lasting mark on the region, both physically and in the minds of those who lived through it. Scientists would continue watching the volcano, knowing that one day, whether in decades or centuries, Mount Spurr would awaken again. The story of the Mount St. Helens eruption in 1980 is one of nature's most powerful and unforgettable moments. Before it erupted, Mount St. Helens had been a quiet and dormant volcano for over 100 years. But nature had other plans, and in the months leading up to May, the mountain began showing signs that something big was about to happen. The first clues came in the form of unusual seismic activity. Scientists had long known that volcanic eruptions were preceded by earthquakes, but these were no ordinary quakes. Starting in mid-March of 1980, small but increasingly frequent earthquakes began to rattle the ground beneath the mountain. These tremors, while initially subtle, grew stronger and more persistent. By the end of the month, the quakes were being felt by residents living in the nearby towns of Washington state. The tremors were strong enough that people living in the area began to wonder if something more dangerous was at play. In addition to the earthquakes, other signs of volcanic activity became more pronounced. Scientists, including volcanologists at the United States Geological Survey, USGS, began to observe swelling on the mountain's north face. This was an indication that magma was rising beneath the surface, increasing the pressure inside the volcano. This swelling was the result of an accumulation of magma and gas beneath the ground, pushing outward and creating what is known as a bulge. As the weeks progressed, the tension surrounding the mountain grew. Local officials, aware of the growing threat, began evacuating residents from areas closest to the volcano, but the vast majority of people in Washington state had no idea how catastrophic this event would turn out to be. The concern was that Mount St. Helens might be headed toward an eruption, but no one could have anticipated the scale of destruction that was about to unfold. On March 27, the volcano sent a dramatic warning shot. A series of powerful tremors caused a massive landslide on the north face of the mountain, resulting in a mud flow that swept across a 24-square-mile area. The eruption of debris and ash was a vivid reminder that Mount St. Helens was waking up, but the worst was still to come. Scientists at the time believed that a major eruption was inevitable, but no one knew exactly when or how catastrophic it would be. These early warnings, however, set off alarms throughout the region, and government officials began preparing for what was to come. Residents living near the volcano grew anxious as they witnessed the increasing seismic activity. In some cases, buildings were damaged from the tremors, and the sky above the mountain was filled with an eerie glow from the increasing number of earthquakes. For weeks, the mountain had been signaling that it was about to burst, but what exactly would happen remained uncertain. People began to evacuate the area in large numbers, unsure if they would ever return home. The stage was set for what would become one of the deadliest and most destructive volcanic eruptions in United States history. As April arrived, the situation became even more serious. Scientists continued to monitor the volcano, and their findings indicated that the threat of a major eruption was becoming more imminent by the day. The frequency of the earthquakes continued to increase, and the bulge on the north face of Mount St. Helens grew larger, a clear sign that magma was continuing to rise. The pressure building inside the volcano was mounting, and every small tremor felt like a reminder that the eruption could come at any moment. During this time, the US government and local authorities took steps to try to mitigate the threat. They declared a state of emergency, and on May 14th, the exclusion zone around Mount St. Helens was expanded, forcing thousands of residents to evacuate. The National Guard was mobilized to assist with evacuation efforts, and the Army Corps of Engineers worked tirelessly to prevent flooding from the nearby rivers. With all this preparation, everyone was holding their breath, waiting for the inevitable. Little did they know that the events of May 18th would change everything, forever. As May approached in 1980, Mount St. Helens continued to show alarming signs that it was ready to erupt. By now, the mountain had become a focal point for scientists, media, and residents alike. For weeks, the volcano had been shaking and groaning, as if awakening from its long slumber, but no one could predict exactly when or how it would erupt. The volcano's internal pressure was steadily increasing, and the landscape around it was beginning to change in dramatic and unexpected ways. The bulge on the north face of the volcano, which had grown steadily since March, became a major point of concern for volcanologists. This bulge, caused by the rising magma beneath the surface, was not only unsettling but also highly unstable. Experts feared that if the pressure within the volcano continued to increase, it could trigger a massive collapse, releasing an explosion of devastating force. The situation was becoming increasingly dire, and the danger was no longer just a possibility, it was becoming an inevitability. In the days leading up to the eruption, seismic activity reached a fever pitch. The quakes were no longer just tremors, they were powerful and violent shakes, rattling buildings and sending shock waves throughout the region. The mountain itself seemed to be trembling with energy, and the ground around it was becoming dangerously unstable. It wasn't just the residents of the nearby towns who felt the impact. These powerful earthquakes were now being felt hundreds of miles away. Amidst this growing unease, scientists were working around the clock to monitor the volcano's every move. Their primary concern was the potential for a lateral blast, a type of eruption where the volcano releases its energy sideways rather than straight up. This was a particularly dangerous scenario because it meant that the explosive force could travel across the surrounding landscape, flattening everything in its path. If this happened, there was little that anyone could do to escape the destruction. By mid-May, the volcano's ominous behavior had prompted officials to take even more drastic action. Evacuations were ramped up, with thousands more people being urged to leave the area. The government implemented roadblocks to prevent anyone from getting too close to the volcano, and the National Guard was deployed to help with evacuation efforts. Yet, despite the growing warnings, there were still some people who were reluctant to leave. Many residents, particularly those who had lived in the shadow of the mountain for years, were hesitant to abandon their homes, convinced that the volcano would not erupt or that the danger was overstated. But for the scientists and emergency responders, the threat was clear. Mount St. Helens was on the brink of a catastrophic event. While the evacuation efforts continued, other precautions were being put in place to mitigate the possible effects of the eruption. The Army Corps of Engineers worked tirelessly to build temporary dams and barriers along the Toutle River, hoping to control any potential flooding caused by the eruption. Flooding was a real concern, as the intense heat of the eruption could melt the snow on the mountain, sending torrents of water, mud, and ash rushing down into the valleys below. It was a race against time, as the threat of an eruption loomed larger with each passing hour. Meanwhile, the growing volcanic activity continued to shake the landscape. Landslides were becoming more frequent, and the slopes of Mount St. Helens were gradually being stripped of trees and vegetation. A few days before the eruption, on May 17th, scientists detected a massive collapse on the volcano's north face, which was followed by an enormous earthquake. This event was the final warning sign that the volcano's pressure was about to reach a breaking point. Everyone knew that it was only a matter of time before Mount St. Helens would unleash its fury. At the same time, the media frenzy surrounding the eruption reached new heights. Journalists from around the world flocked to the area, eager to document the impending disaster. Helicopter footage of the swollen mountain and the surrounding areas began to fill the news broadcasts. People watched with bated breath as scientists, journalists, and emergency workers all braced for the inevitable. In the days before May 18th, some of the most seasoned volcano experts in the world were still unsure about exactly what would happen next. They had studied volcanic eruptions for years, but the potential force of an eruption like the one Mount St. Helens seemed poised to unleash was unprecedented. Would it be a gentle steam release, or would it be a catastrophic explosion that could level everything in its path? Unfortunately, the world would soon find out, but no one could have prepared for the scale of devastation that would follow. The morning of May 18th, 1980, started like any other spring day in the Pacific Northwest, calm, quiet, and deceptively serene. But beneath the surface, Mount St. Helens was preparing to unleash its fury. The seismic activity had been intensifying for weeks, but now it was no longer just a threat. It was an impending catastrophe. The people living in the nearby towns, though aware of the growing danger, had no idea that the eruption would be unlike anything the world had ever seen. At 8:32 a.m., all that changed. The earth beneath Mount St. Helens rumbled, and the pressure built to its breaking point. Without warning, the volcano erupted with an explosive force that shook the entire region and could be heard as far as 200 miles away. What followed was not just a typical volcanic eruption, but one of the most violent and devastating explosions in modern history. The eruption began with a massive lateral blast, unlike any eruption ever seen before. The north face of Mount St. Helens, which had been bulging ominously for weeks, collapsed in a massive landslide. This was no ordinary landslide. This was the beginning of a catastrophic release of energy. As the landslide slid down the mountain, it triggered a violent eruption that sent a massive wall of ash, gas, and rock shooting out sideways at speeds of up to 300 miles per hour. The sheer force of the blast flattened everything in its path. Trees were snapped like matchsticks, and entire forests were obliterated across a 230 square mile area. The land was scoured clean, leaving behind a desolate wasteland. The intensity of the explosion was so powerful that it changed the landscape of the area forever. The eruption was followed by a massive ash cloud that rose high into the sky, reaching altitudes of over 80,000 feet, high enough to disrupt air travel across much of the United States. The cloud of ash spread quickly, darkening the skies and blocking out the sun. For those near the volcano, the skies turned an eerie, sulfurous yellow, and the air grew thick with ash, making it difficult to breathe. As the ash began to settle, it became clear just how catastrophic the eruption had been. The initial blast had been just the beginning. Over the course of the next 9 hours, Mount St. Helens continued to erupt, sending more ash and debris into the atmosphere and creating pyroclastic flows, fast-moving avalanches of hot gas, rock, and ash that raced down the mountainside. The eruption's energy was so intense that it was equivalent to the explosive power of 1,600 Hiroshima-sized atomic bombs. As the ash continued to spread across the region, it brought with it darkness and chaos. The thick ash cloud affected not just the local communities, but also areas hundreds of miles away. In Seattle, more than 200 miles to the northwest, the sky darkened to an unnatural twilight, and the air was thick with dust. Roads were covered in ash, and the landscape was completely transformed. The eruption was felt across the western United States, with ash falling as far as Colorado. It was a surreal, apocalyptic scene, one that seemed to stretch on for days. While the eruption raged on, the immediate aftermath was devastating. The shockwave of the explosion reached as far as the nearby towns, and the surrounding area was quickly blanketed in ash. By the time the eruption had subsided, the town of Spirit Lake was unrecognizable. The lake itself had been choked with debris, and entire sections of forest had been obliterated. Rescue efforts became nearly impossible, as the ash created an impenetrable layer over the land, burying roads, homes, and anything else in its wake. Communication lines were severed, and the region was cut off from the outside world. The most tragic aspect of the eruption was the loss of life. 57 people were confirmed dead, though many others were feared to have perished in the eruption's wake. Among the casualties were local residents, scientists, and adventurers who had been observing the volcano's activity in the days leading up to the eruption. One of the most notable victims was volcanologist David A. Johnston, who was stationed at an observation post near the mountain. As he communicated with the U.S. Geological Survey, Johnston's final words were chilling. "Vancouver, this is it," before he was tragically killed in the eruption. His death, along with the deaths of many others, was a sobering reminder of the unpredictable and deadly nature of volcanic eruptions. As the ash continued to fall, the volcano's eruption sparked not just widespread destruction, but also a deep sense of awe at the raw power of nature. What had once been a quiet and dormant volcano had now become one of the most violent and destructive natural disasters in history. The eruption of Mount St. Helens had left a lasting scar on the landscape, but it also changed the way scientists would approach volcanic eruptions in the future, and served as a stark reminder of the unpredictable forces at work beneath the Earth's surface. The eruption of Mount St. Helens on May 18, 1980, had forever altered the landscape of Washington state, but the true scale of its aftermath was not fully realized until days, months, and even years later. The immediate devastation left behind was staggering. The once thriving forested areas were now reduced to barren wastelands, stripped of vegetation, wildlife, and the towering trees that had defined the region for centuries. Entire ecosystems were wiped out, and the earth itself was left scarred, as if nature had been reset in an instant. In the wake of the eruption, the human toll was devastating. The loss of 57 lives, many of whom had been in the danger zone despite evacuation orders, was just the beginning of the broader, long-term consequences. Hundreds of homes were destroyed, and entire communities found themselves displaced, with people left to rebuild their lives from the ground up. The destruction of the timber industry alone was a blow to the region's economy, as vast swathes of forest land had been decimated. The ash fall, which had blanketed homes, farms, and businesses for miles, had further disrupted daily life, causing widespread destruction of crops and infrastructure. The environmental impact was also catastrophic. The blast zone, once rich in flora and fauna, was now a vast, lifeless expanse. The loss of vegetation meant that the soil would no longer be able to support agriculture, and it would take years for nature to begin the slow process of recovery. The ecosystems that had existed for centuries were disrupted, and many species of animals, including some native to the area, were forced to adapt or perish. Spirit Lake, a pristine natural wonder that had been a popular recreational spot before the eruption, was severely affected. The massive mudflows, which had poured into the lake during the eruption, raised its water level significantly and caused debris to flood its shores. The once beautiful lake was now clogged with ash, logs, and other debris. The volcanic ash, which had fallen over 11 states, also had a profound impact on both the local and national level. The ash cloud, which reached high into the atmosphere, disrupted air travel, forcing airports to close and delaying flights for days. It was so thick that it caused the sky to turn dark, even in cities far from Mount St. Helens. On the ground, the ash created a choking haze that made it difficult to breathe, with residents wearing masks and trying to protect themselves from inhaling the dangerous particles. The ash also contaminated drinking water supplies, and it took months for affected communities to restore normal services. Many areas had to undergo extensive cleanup efforts as the fine ash found its way into everything: homes, businesses, and even the engines of vehicles, which caused mechanical failures and accidents. The economic effects of the eruption were felt across the Pacific Northwest, especially in the timber industry, which had been one of the region's largest sources of income. With vast tracts of forest destroyed, the timber industry faced significant challenges in its recovery. It would take years to restore even a fraction of the lost forest, and the region's economy was forced to adjust to the new reality of a world without the towering trees that had once stood proudly along the mountainsides. Despite the overwhelming loss and destruction, Mount St. Helens also became a symbol of resilience and renewal. Over time, the area began to recover. Volunteers, scientists, and local communities worked together to rebuild roads, clean up debris, and restore services. Scientists, too, saw the eruption as an opportunity to study the rapid changes to the ecosystem and the rebirth of the land. Over the decades that followed, the landscape slowly began to show signs of life once again, with new plant species growing and animals gradually returning to the region. It became a living laboratory where researchers studied the resilience of nature and the ability of ecosystems to recover from catastrophic events. While the recovery process took years, the eruption also provided vital lessons for the scientific community. The eruption of Mount St. Helens demonstrated the unpredictability of volcanic activity and the importance of monitoring volcanoes closely. The disaster prompted changes in volcanic monitoring methods, as well as improvements in early warning systems for residents living near active volcanoes. The lessons learned from Mount St. Helens helped save countless lives in future eruptions and made the world more prepared for volcanic events. Though Mount St. Helens has slowly healed over time, it remains an enduring reminder of the power of nature and the unpredictable forces that shape our planet. The eruption was a humbling moment in history, one that left scars on the land and the people who witnessed it, but also gave birth to new opportunities for scientific discovery and environmental renewal. The mountain itself stands as a monument to resilience, both human and natural, and serves as a constant reminder that while we can never fully control the forces of nature, we can learn from them, adapt, and rebuild. In the middle of the ocean between the islands of Java and Sumatra, there was a small but powerful volcano known as Krakatoa. It sat in the Sunda Strait, part of a chain of islands in what is now Indonesia. At first glance, it didn't seem especially dangerous. It was just one of many volcanic islands in the region, mostly covered in trees, with steep rocky slopes and quiet coastlines. But Krakatoa had a violent past. Old records and local legends told of earlier eruptions long before the 19th century. Some even said entire civilizations may have been affected by Krakatoa's earlier explosions. Scientists later found layers of volcanic rock in the area that hinted at a massive eruption many centuries earlier, possibly one of the largest the world had ever seen. By the 1800s, the volcano had been silent for a long time. People lived on nearby islands and along the coasts of Java and Sumatra without much worry. The waters around the island were busy with trade ships and fishing boats. The land was rich and full of life. Then, in May of the year 1883, the first clear sign appeared that something was changing. Without warning, Krakatoa began to rumble. A column of ash shot into the sky, surprising nearby ships and startling villagers who could see the black cloud from miles away. At the time, it didn't seem too serious. Many believed the volcano was just letting off a bit of pressure. But scientists of the time, including Dutch colonial officials, took notice. Some began to record the strange activity, keeping notes on the ash, the small earthquakes, and the changing color of the sea near the island. Still, no one could have predicted what was coming. What started as a quiet island in the sea was about to become the center of one of the most powerful natural disasters in recorded history. By the middle of August, in the year 1883, Krakatoa was no longer quiet. The warning signs had become impossible to ignore. A thick black cloud hung over the island, and loud booming sounds echoed across the sea. Ships passing through the nearby Sunda Strait reported seeing ash fall onto their decks. Some described the strange sight of lightning flashing from inside the ash cloud, something now known as volcanic lightning. On Sunday, August 26th, the first massive explosion happened just after noon. It was so loud that it was heard more than 1,000 miles away in Perth, Australia, and even farther in places like the island of Rodriguez, over 2,800 miles away. People thought it was the sound of gunfire or cannon blasts, but this was only the beginning. That evening, and into the early morning hours, the volcano erupted again and again, each time with more force. The island was breaking apart from within. Tremors shook the ground and the sky turned completely dark with ash. The sun disappeared behind thick clouds of dust and rock, and it seemed like night had fallen in the middle of the day. Then came the largest explosion of all. On the morning of Monday, August 27th, just before 9 o'clock. The force of this final blast was unlike anything anyone had ever seen. A huge part of Krakatoa, including the entire northern portion of the island, was blown apart. The explosion sent ash and rock more than 20 miles into the sky. The pressure wave from the blast traveled around the entire world 4 times. Nearby islands were devastated. Coastal towns on Java and Sumatra were shaken to their foundations. But the worst part was not the explosion itself. It was what followed, a massive, deadly tsunami. After the final eruption tore Krakatoa apart on the morning of Monday, August 27th, the force of the explosion triggered something just as deadly, a massive tsunami. As the volcano collapsed into the sea, it displaced millions of tons of water, sending waves racing in all directions. The tsunami struck the nearby coastlines of both Java and Sumatra with almost no warning. Entire villages were swallowed up in minutes. In some places, waves reached as high as 120 feet. Fishing boats were thrown far inland. Houses, markets, and then mosques were reduced to splinters and carried away by the water. People who had survived the ash and falling debris now found themselves facing an even greater danger, the ocean itself. Some of the most devastating damage occurred in the town of Merak, on the coast of Java. Eyewitnesses described how the sea suddenly pulled back, leaving fish flopping in the sand. Then a towering wall of water appeared on the horizon. Within seconds, it crashed into the town, wiping it off the map. No buildings were left standing. Farther away on the island of Sumatra, the waves still reached with terrifying force. One survivor from a coastal village described climbing a tree to escape the water, only to be thrown back down as the tree was torn from the ground. Entire families disappeared. Those who lived through it often did so by clinging to pieces of wood or floating in the floodwaters for hours. Even ships at sea were affected. Some vessels reported being lifted and thrown by the sudden waves, while others vanished without a trace. Ports as far away as Sri Lanka and India recorded strange water movements caused by the tsunami. In the Indian Ocean, the shockwaves continued to ripple outward, eventually being recorded on tide gauges as far as South Africa and even the English Channel. The death toll was staggering. Over 36,000 people lost their lives, most of them from the tsunami. In many coastal areas, there were simply no survivors to tell what happened. The landscape was changed completely, towns erased, harbors reshaped, and the coastline carved anew by the sea. Krakatoa's eruption was over, but the suffering had only just begun. The people who lived through it faced a world that looked nothing like the one they had known the day before. After the eruption and the tsunami, Krakatoa's effects continued to spread far beyond Indonesia. In the weeks and months that followed, people around the world began noticing strange and beautiful changes in the sky. Sunsets turned deep red and orange. Some places reported purple twilights and golden clouds. In cities like London, New York, and Rio de Janeiro, the sky glowed in unusual colors long after the sun had gone down. These changes were caused by the massive amount of volcanic ash and gas that Krakatoa sent into the upper atmosphere. That ash spread across the globe, carried by high winds, sunlight hitting the tiny particles scattered in a different way, causing the strange colors. People did not know at the time that what they were seeing was connected to a volcanic eruption on the other side of the world. In some countries, people thought the red skies were signs of war or a message from God. Artists and writers tried to capture the strange light in paintings and poems. One of the most famous paintings from that time, The Scream by Edvard Munch, is believed to have been inspired by the red sky that followed Krakatoa's eruption, but the ash did more than change the sky. It also affected the weather. The sunlight that reached the Earth's surface was slightly reduced, causing global temperatures to drop. The year after the eruption, many places reported colder weather and strange patterns in rain and snowfall. This cooling effect was felt for more than a year. Scientists at the time were still learning about volcanoes, but Krakatoa helped change that. It was one of the first natural disasters to be studied using worldwide communication. Reports from telegraph offices and weather stations were collected and compared. The event helped scientists understand how volcanic eruptions could affect the whole planet. Krakatoa's eruption also taught a painful lesson about warning systems and preparedness. Many people living near the volcano had no idea of the danger they were in. Afterward, efforts slowly began to improve ways to monitor volcanoes and oceans. Today, that tragic eruption is one of the reasons early warning systems exist for tsunamis and volcanic activity. In the end, the eruption of Krakatoa in the year 1883 was more than just a disaster for Indonesia. It was a global event that shook the earth, changed the sky, and left a deep mark in both science and memory. The volcano itself was mostly destroyed, but its story still lives on as one of the most powerful and far-reaching natural events in human history. Mount Fuji is one of Japan's most famous landmarks, but beneath its beauty lies a serious threat. It is an active volcano, and though it has been dormant since its last eruption more than 300 years ago, scientists warn that an eruption is still possible. If Mount Fuji were to erupt tomorrow, it could have devastating consequences, not just for Japan, but for the entire world. The Japanese government has been preparing for such a scenario for years. Experts have studied past eruptions, including the massive Hoei eruption more than 300 years ago, to understand what might happen. That eruption blanketed parts of Tokyo, then known as Edo, in thick layers of ash. A modern-day eruption could be even more catastrophic, as Japan's population and infrastructure have grown significantly since then. Scientists closely monitor Mount Fuji for any signs of activity using seismic sensors, satellite imagery, and gas analysis. Although there are currently no immediate warnings, the possibility of an eruption remains. Mount Fuji is part of the Fuji Volcanic Zone, a chain of volcanoes driven by the subduction of tectonic plates beneath Japan. Over time, pressure builds up beneath the surface, and when it finally releases, it can lead to a major eruption. If an eruption were to happen tomorrow, the first sign would likely be an increase in earthquakes beneath the mountain. These tremors would indicate magma rising toward the surface. Scientists would rush to analyze the data, but there might not be much time before the volcano erupts. Within hours or even minutes, explosions could begin at the summit, sending ash and volcanic gases high into the sky. The initial eruption would likely be violent, with lava and ash spewing from the crater. Depending on the size of the eruption, the immediate area around Mount Fuji could be devastated. The surrounding region, including the Yamanashi and Shizuoka prefectures, would be covered in volcanic debris. The force of the eruption could trigger landslides, further endangering those nearby. One of the biggest concerns is the impact on Tokyo, which lies about 100 miles away. Even though the city is not directly next to Mount Fuji, the wind could carry ash clouds toward the capital. A heavy ash fall could disrupt daily life, making it difficult to breathe and reducing visibility. The government has advised residents to stay indoors in case of such an event, as inhaling volcanic ash can cause severe respiratory problems. Air travel would be among the first things affected. Flights across Japan and possibly beyond would be grounded as the ash cloud spreads. Volcanic ash is extremely dangerous for aircraft, as it can clog engines and damage instruments. In past eruptions around the world, flights have been cancelled for days or even weeks. If Mount Fuji erupts, Japan's busy airports could come to a complete standstill. The eruption could also cause power outages and disrupt essential services. Ash can accumulate on power lines, causing them to collapse under the weight. Water supplies could be contaminated, and internet and phone networks might go down in affected areas. The government would need to act quickly to ensure that emergency services remain functional and that residents have access to clean water and electricity. This hypothetical scenario is not just speculation. Japan has been making detailed preparations in case Mount Fuji erupts. The government has already released guidelines for residents, advising them to store at least 2 weeks' worth of food and water. Officials have also mapped out evacuation routes and designated shelters. However, no one can predict exactly when the next eruption will happen. Scientists warn that even though Mount Fuji appears calm now, it could erupt at any time and the consequences could be catastrophic. As we move on, we will explore how the eruption could unfold over the first few days and the long-term damage it could cause. As the eruption of Mount Fuji continues into its first full day, the situation worsens. The initial explosions have sent ash and volcanic gases high into the atmosphere, and the skies above central Japan are darkened. The once iconic peak of Mount Fuji is now covered in thick clouds of smoke, obscuring it from view. Tremors still shake the ground, a sign that the eruption is far from over. With strong winds pushing the ash eastward, Tokyo and its surrounding regions begin to experience significant ashfall. But even though the city is not close to the volcano, fine volcanic ash can travel hundreds of miles. A light dusting coats streets, rooftops, and vehicles, turning the landscape an eerie gray. Residents who venture outside wear masks and protective glasses, as breathing in the fine particles can cause lung irritation and other health issues. Hospitals see an increase in patients suffering from breathing difficulties, and those with pre-existing conditions like asthma are particularly at risk. The weight of the ash also starts to take a toll on infrastructure. Although only a few centimeters have accumulated in some areas, it is enough to clog drainage systems, making roads slippery and dangerous. If the eruption continues, heavier ashfall could collapse roofs, disrupt transportation, and cause severe structural damage. Officials work urgently to clear major highways, but visibility is low, and driving conditions remain hazardous. Japan's famed bullet trains, known for their speed and efficiency, are halted as a precautionary measure. Even a small amount of ash can interfere with train operations, and major railway lines suspend service until the tracks can be cleared and the risk assessed. In some areas, bus services and subways continue running, but delays and overcrowding become widespread. With public transportation disrupted, people struggle to reach their workplaces, and businesses begin shutting down. Air travel remains at a standstill. Airports in Tokyo, Osaka, and Nagoya cancel all flights, as volcanic ash poses a serious threat to jet engines. The international impact begins to grow as flights scheduled to land in Japan are diverted, and airlines worldwide adjust their schedules to avoid the expanding ash cloud. The economic consequences of these disruptions are already being felt, as Japan is a major hub for international business and tourism. Meanwhile, closer to the eruption site, thousands of residents in the surrounding prefectures have been forced to flee. Evacuations continue as emergency shelters fill with people seeking refuge. Some roads leading away from Mount Fuji are covered in ash or partially blocked by falling debris, making travel slow and difficult. Authorities use helicopters and boats to evacuate those stranded in the hardest hit areas. As the hours pass, scientists monitoring the eruption analyze data to determine how long it may last. Volcanic activity can be unpredictable. Some eruptions weaken within days, while others continue for weeks or even months. If Mount Fuji follows the pattern of its past eruptions, the danger is far from over. The presence of pyroclastic flows, fast-moving currents of hot gas and volcanic material, is another major concern. These flows, which can reach speeds of hundreds of miles per hour, are impossible to outrun and can destroy everything in their path. Japan's government urges citizens to remain indoors if they are not in immediate danger. Many people have already stocked up on emergency supplies as recommended by officials, but stores in unaffected areas experience a surge in panic buying. Essentials like bottled water, non-perishable food, and batteries disappear from shelves within hours. Online orders for air purifiers and protective masks skyrocket as people prepare for prolonged exposure to ash. As we continue, we will examine the long-term consequences of the eruption, including its impact on the environment, agriculture, and Japan's economy. In the days following Mount Fuji's eruption, the scale of the disaster becomes more evident. The initial explosion was only the beginning, and now the lingering effects of the eruption begin to reshape daily life across Japan. As the ash cloud continues to spread, concerns shift from immediate evacuations to the long-term consequences that could last for months or even years. One of the most pressing issues is the growing strain on Japan's economy. The closure of airports, highways, and train lines has already caused billions of dollars in losses, and as time passes, more industries feel the impact. Factories, in the Bein-Nakaba, in the Tokyo-Yokohama region, some of the country's most important manufacturing hubs, are forced to suspend operations. Ashfall has contaminated water supplies in some areas, forcing businesses that rely on clean water, such as semiconductor plants and food processing facilities, to shut down temporarily. In rural areas surrounding Mount Fuji, farmers face a crisis of their own. Crops covered in even a thin layer of volcanic ash can be damaged beyond repair. Rice fields, vegetable farms, and tea plantations are particularly vulnerable as the ash alters the soil's pH levels and blocks sunlight from reaching plants. Livestock farmers also struggle as volcanic ash contaminates grazing fields and water sources, making it difficult to feed their animals. With food production disrupted, grocery stores in Tokyo and other major cities begin to see shortages, driving up prices and increasing pressure on supply chains. The eruption's impact extends beyond Japan's borders. Countries that import Japanese goods, particularly automobiles and electronics, face delays as factories remain closed. The stock market reacts with uncertainty, and investors closely watch how Japan's government handles the crisis. Meanwhile, tourism, a major part of Japan's economy, has come to a standstill. The famous Mount Fuji, once a symbol of beauty and tranquility, is now a disaster zone. Popular destinations like Hakone and the Fuji Five Lakes region, known for their scenic views, have been evacuated, and hotels that once hosted thousands of visitors now sit empty. Environmental consequences also start to unfold. The ash cloud that drifted over the Pacific Ocean has begun affecting neighboring countries, with reports of fine ash reaching parts of South Korea and China. While the amount is not enough to cause serious damage, air quality levels have dropped in some areas. Scientists monitor the situation closely, as a prolonged eruption could lead to further disruptions in weather patterns, similar to how past volcanic eruptions have caused temporary cooling on a global scale. Japan's government, already working around the clock to manage the disaster, now faces another challenge: the massive cleanup effort. Removing volcanic ash from roads, buildings, and waterways is a slow and expensive process. In some areas, the ash has mixed with rain, forming a thick, cement-like sludge that clogs drainage systems. This increases the risk of flooding, especially in low-lying areas near Tokyo. Authorities deploy thousands of workers and military personnel to clear the streets, but progress is slow, and officials warn that it could take months to fully restore infrastructure. As the cleanup continues, scientists assess the state of Mount Fuji itself. The mountain's shape has been altered by the eruption, with new craters and fissures forming near the summit. Researchers conduct aerial surveys and analyze seismic activity to determine whether another eruption could occur. While the current eruption has started to weaken, experts warn that volcanic activity often comes in cycles. If magma continues to build up beneath the surface, additional eruptions could follow in the coming months. In the next part, we will explore how Japan's emergency response teams are handling the crisis, the ongoing evacuation efforts, and the challenges of rebuilding communities affected by the disaster. With Mount Fuji's eruption leaving much of central Japan in crisis, emergency response efforts shift toward long-term survival and recovery. While the immediate danger has lessened, the aftermath presents new challenges, and the full scope of destruction is still unfolding. The Japanese government and international aid organizations work tirelessly to assist displaced residents, restore essential services, and prevent further disasters from emerging in the wake of the eruption. Evacuations remain a top priority as many areas are still unsafe. The thick layers of ash covering homes, schools, and businesses have made entire towns uninhabitable. Even areas that initially seemed unaffected now face new risks: structural damage from the weight of ash, contaminated water supplies, and the increased likelihood of landslides. Heavy rains in the region could mix with loose ash deposits, triggering massive mud flows that threaten both urban and rural areas. Authorities closely monitor these conditions and expand evacuation zones as needed, sending thousands more to shelters in safer regions. Inside these shelters, overcrowding and limited resources create difficult living conditions. Despite efforts to stockpile supplies ahead of time, the sheer number of evacuees puts immense strain on food, clean water, and medical care. Hospitals struggle to keep up with the influx of patients suffering from respiratory issues caused by inhaling volcanic ash. While face masks help reduce exposure, prolonged breathing of fine ash particles can lead to severe lung problems, particularly for children, the elderly, and those with pre-existing conditions. Mobile clinics are set up near evacuation sites, but healthcare workers warn that without improved air quality, respiratory illnesses will continue to rise. Beyond the health crisis, Japan's infrastructure faces overwhelming challenges. Railways and highways leading into Tokyo remain partially shut down due to persistent ash accumulation. Bullet trains, known for their speed and efficiency, operate at a fraction of their normal capacity, and airlines struggle to resume flights as ash continues to affect air traffic. The financial burden of maintaining these closures grows daily, adding to the already staggering economic toll. Government officials estimate that full restoration of transportation networks could take months, further delaying recovery efforts. the energy sector is also under strain. Ash has coated solar panels, rendering them ineffective, and power plants located near the base of Mount Fuji remain offline due to damage. While emergency generators help prevent widespread blackouts, officials warn of possible electricity shortages, especially as demand rises in colder months. The Japanese government urges citizens to conserve power wherever possible, implementing scheduled blackouts in some regions to manage supply. Despite these hardships, Japan's response to the disaster demonstrates resilience and preparedness. The government, already experienced in handling natural disasters such as earthquakes and tsunamis, coordinates relief efforts with military precision. Volunteers from across the country arrive to assist with cleanup operations, and engineers work around the clock to clear roadways and reinforce damaged buildings. International aid also pours in, with countries sending financial assistance, medical supplies, and rescue teams. Meanwhile, scientists continue monitoring Mount Fuji, analyzing gas emissions and seismic activity to determine if further eruptions could occur. While the worst appears to be over, they warn that Japan must remain on high alert. History shows that volcanoes can have prolonged eruptive periods, sometimes lasting months or even years. If new activity is detected beneath Mount Fuji, evacuation plans may need to be extended indefinitely, forcing many residents to reconsider their futures. As Japan moves from emergency response to long-term recovery, the nation faces tough decisions about rebuilding. Some communities near Mount Fuji may never be safe to return to, and large-scale relocation efforts could be necessary. The eruption has left scars not only on the landscape, but also on the people who call this region home. The road to recovery will be long, but Japan's history of resilience suggests that even in the face of such a catastrophe, the country will rebuild, adapt, and emerge stronger than before. As we wrap up, we will examine the long-term consequences of the eruption, from global economic effects to the future of Mount Fuji itself. As Japan begins the long process of recovery, the global impact of Mount Fuji's eruption becomes increasingly clear. While the immediate crisis has passed, the long-term consequences are only beginning to unfold. From economic disruptions to environmental changes, the effects of this event will be felt for years. One of the most significant global impacts is on trade and commerce. Japan, a major player in global markets, faces challenges as industries struggle to recover. Manufacturing plants shut down due to ash contamination, supply chains remain disrupted, and exports slow as ports along the Pacific coast work to clear debris and repair damage. The electronics and automotive industries, which rely on precision manufacturing, are particularly affected, causing ripple effects in international markets. Companies dependent on Japanese parts and technology experience delays, driving up costs worldwide. Tourism, a key part of Japan's economy, also suffers. Mount Fuji, once a major attraction, is now a restricted zone due to unstable ground and ongoing seismic activity. Popular travel destinations across central Japan report massive declines in visitors, and airlines struggle to resume normal operations. While the government plans to launch recovery campaigns to rebuild tourism, the uncertainty surrounding Mount Fuji's condition leaves many hesitant to return. Environmental consequences extend far beyond Japan's borders. The vast amount of volcanic ash released into the atmosphere affects global weather patterns. Scientists observe a temporary cooling effect as the fine particles reflect sunlight away from the Earth's surface. This could lead to unusual weather conditions in the coming years, altering monsoon patterns in Asia and affecting agricultural production in regions thousands of miles away. Crop yields in various countries may decline, leading to food shortages and price increases. Closer to the eruption site, the natural environment undergoes drastic changes. Rivers and lakes near Mount Fuji become polluted with ash, affecting aquatic life and local water sources. Forests on the slopes of the mountain, once lush and vibrant, are now barren, covered in layers of gray ash. Wildlife that once thrived in these ecosystems struggles to survive, forcing species to migrate or face extinction in the area. Scientists begin long-term studies on how the eruption has altered the region's biodiversity and what recovery efforts may be needed. For the people of Japan, the psychological and cultural impact of the eruption cannot be overstated. Mount Fuji, long considered a sacred symbol of the nation, now stands as a reminder of both nature's power and the fragility of human existence. Many who lived in its shadow their entire lives must now relocate permanently, leaving behind homes, businesses, and generations of history. The Japanese government provides financial aid and relocation assistance, But rebuilding lives proves to be just as difficult as reconstructing cities. Despite the devastation, Japan demonstrates remarkable resilience. Reconstruction efforts begin almost immediately, with engineers designing stronger buildings, improved evacuation routes, and better infrastructure to withstand future disasters. Scientists use new data from the eruption to refine prediction models, hoping to improve early warning systems. The experience serves as a reminder of the importance of preparation, not just for Japan, but for nations worldwide that live in the shadow of active volcanoes. As time passes, Mount Fuji will slowly recover, and so will the communities that surround it. Though its landscape has changed, its significance remains. The eruption of Mount Fuji is a defining event in Japan's history, one that reshapes the country but does not break it. The lessons learned from this disaster will help guide future generations, ensuring that even in the face of nature's most powerful forces, humanity continues to adapt and endure. Mount Pelée sat quietly on the island of Martinique in the Caribbean for a long time. Most people living nearby had no memory of it ever erupting. It had shown some signs of activity in the past, small eruptions in the years 1792 and 1851, but nothing that caused real fear. Because of this, people thought of the volcano as more of a natural landmark than a threat. Life in the town of Saint-Pierre, just over 6 miles south of the mountain's summit, went on as usual. It was a busy and beautiful place known as the Paris of the Caribbean, with shops, schools, a theater, and busy streets. In early April of the year 1902, a few locals noticed something odd. People hiking near the mountain reported strange smells like rotten eggs coming from the summit. These smells were from sulfur gases leaking out of small cracks called fumaroles. But sulfur fumes weren't all that new for the area, and no one thought much of it. That changed on April 23rd when the volcano let out its first real sign of trouble. A light rain of ash and small rocks fell on the southern and western sides of the mountain. Tremors shook the ground. People in the nearby villages felt it, but most still believed it would pass. By April 25th, a dark cloud of ash and rock shot up from the volcano's top. It looked frightening, but it didn't do much damage. Even then, local leaders didn't raise the alarm. On April 26th, another blast dusted nearby towns in gray ash. The volcano was clearly waking up, but officials continued to believe it posed no serious risk. 2 days later, on April 27th, a group of curious hikers made their way up to the summit. What they saw was shocking. The once dry Etong Sek crater was now a lake, boiling and steaming. A cone of volcanic debris, about 50 feet high, had formed beside it. Hot water poured into the lake, and the deep rumbling from below the earth sounded like a huge pot boiling over. The smell of sulfur had become so strong that it reached the streets of Saint-Pierre, causing people and animals to gag or flee indoors. By the end of April, rivers running down the mountain swelled. Some carried trees and boulders with them. Ash started falling steadily on villages like Prêcheur and Saint-Philomène. Even though these were clear warning signs, people living in and around Saint-Pierre still didn't leave. Many believed the volcano would settle down again, just like it had in the past. Others thought the city was too far from danger. After all, it was over 6 miles from the summit. On the night of May 2nd, around 11:30, the volcano exploded again. It sent out a huge black cloud of ash and pumice, and the explosions grew louder. The ground trembled. Ash rained down on the northern half of the island, and the air became hard to breathe. These blasts were now happening every 5 or 6 hours. Even with all of this happening, life in Saint-Pierre mostly went on as usual. People were nervous, but there was no order to leave, no official word telling them what to do. That weekend, a local newspaper decided to cancel a picnic planned for May 4th, just to be safe. It was one of the few signs that people were starting to worry. Farm animals, however, had already begun dying from starvation and thirst. Their food and water had been covered in ash, making it impossible for them to eat or drink. The island was clearly changing, but the people didn't fully realize what was coming. In the days ahead, things would go from bad to deadly. And yet, even as the ground rumbled beneath their feet and the sky darkened with ash, most people stayed put, unaware that their time was running out. By the end of April in the year 1902, the signs coming from Mount Pelée were growing harder to ignore. Even though many locals still believed there wasn't much to worry about, the mountain was changing quickly. Ash was falling almost daily, and the smell of sulfur filled the air around Saint-Pierre. Nearby rivers started to swell with muddy water, carrying fallen trees and rocks down from the slopes. On April 27th, Some people climbed up to check out the Etang Sek crater. They found a lake of boiling water nearly 200 meters across, with steam hissing from deep underground and a strong sulfur smell in the air. That same smell drifted as far as the city of Saint-Pierre, which was over 6 kilometers away. Farm animals were beginning to suffer too. With ash covering the ground and falling into streams, there was no clean water or grass for them to eat. The air burned the lungs, and horses and cattle were getting sick or dying. Still, the local government didn't take serious action. The mayor and other officials were more focused on an upcoming election. Even though the volcano was getting louder and more aggressive each day, they insisted that everything was under control. On May 2nd, at around 11:30 at night, Mount Pelée let out a huge explosion. A thick black cloud of ash and smoke shot up into the sky. Earthquakes shook the ground, and the entire northern part of the island was soon covered in a layer of gray dust. The noise could be heard for miles, and even the ground itself seemed to be groaning under the pressure. But despite the chaos, people still stayed in the city. Some were scared but didn't know where else to go. Others simply trusted that the worst had passed. There were more explosions through the night and into the next day. Every 5 to 6 hours, the volcano would erupt again, the sky darkened, and the air was thick with ash. Even breathing became harder. Still, there was no official order to evacuate. Instead, there were efforts to calm the population. Newspapers printed updates but didn't sound the alarm. In fact, one local paper had planned a picnic on the mountain for May 4th, but ended up postponing it, not because of fear of the volcano, but because of poor visibility from the ash. On May 5th, things took a deadly turn. A powerful mud flow came rushing down the southwest side of the mountain. It smashed into a sugar mill, burying around 150 people and sweeping debris all the way to the sea. The mud flow hit the ocean with such force that it triggered 3 separate tsunamis. These waves damaged coastal buildings, sank boats, and caused panic among the people living near the water. That night, the volcano exploded again, but this time the clouds weren't just dark smoke. Parts of the eruption were glowing. Lava had finally reached the surface, marking a major shift in the eruption's behavior. By now, Mount Pelée was fully awake, and its power was growing. The eruptions were no longer just about steam and gas. Real magma was involved now, which meant the danger was about to reach a whole new level. And still, with everything that had happened, Saint-Pierre remained full of people. Residents, shopkeepers, families, and even refugees from nearby villages who thought the city would be a safe place to ride out the storm. They couldn't have known that they were waiting at the foot of one of the most deadly volcanic eruptions in modern history. By May 6th, the atmosphere in Saint-Pierre had shifted from nervousness to unease. The skies were darker than usual, filled with thick ash clouds that blocked out the sun. Street lamps stayed lit during the day, and layers of ash coated the rooftops, trees, and streets like gray snow. Breathing was difficult, and many people covered their faces with damp cloths. Horses, birds, and pets were found dead from the poor air quality, and the smell of sulfur never went away. Still, ships continued to arrive in the harbor, and life carried on as best as it could. Inside government buildings, officials tried to maintain order. The governor of Martinique, Louis Moutet, had recently visited the city with his wife. He wanted to reassure citizens that they were not in danger. He even moved into the city for a few days to calm fears. At the same time, reports were coming in from across the island about the mountain's activity, small earthquakes, boiling mud, glowing gas, and loud explosions, but the response remained the same: stay calm. Meanwhile, Mount Pelée was going through serious internal changes. A lava dome had begun forming inside the crater. This meant magma was rising to the surface, but being trapped beneath hardened rock. The pressure beneath this cap was increasing rapidly, and gas was building up faster than it could escape. On May 7th, another powerful explosion blew ash and rocks thousands of meters into the air. Some stones fell into the city, crashing through roofs and damaging homes. People were now seriously frightened, but most still remained. Many didn't have the means to leave, and others believed the worst had already happened. In the hills around the volcano, entire forests were dying from the toxic gases. Banana trees and sugar cane fields turned black. Streams ran hot, and fish floated to the surface, dead. The ground cracked in strange patterns, and wild animals fled or dropped where they stood. But inside Saint-Pierre, many still held on to hope. Markets were open, churches held services, and people tried to continue their lives even as the ground shook beneath them. On that same day, scientists visiting the area tried to gather data about the volcano's behavior. They noticed that the gas emissions were becoming more violent and that the shape of the crater had changed. But their warnings went mostly unheard. The newspapers printed short updates but downplayed the danger. There was a strong sense of denial throughout the island's leadership. In their view, St. Pierre was too important to lose. It was the economic and cultural heart of the island, and abandoning it would have been unthinkable. What no one realized was that Mount Pelée had become something far more dangerous than anyone had seen before. It wasn't just releasing steam and ash, it was preparing for a type of eruption almost no one on the island understood. And with each hour that passed, the force inside the mountain kept growing, pushing toward the moment when everything would change forever. On the morning of May the 8th, 1902, St. Pierre woke to a strange stillness. The usual tremors had stopped. The sky was heavy with ash, but there was no wind, no birds, and no sound from the mountain. Many residents took this quiet as a sign that the worst had passed. Others were too exhausted to think clearly, having spent the last several nights in fear. Despite the chaos of the past days, thousands still remained in the city. Families, merchants, teachers, and workers who had nowhere else to go. At approximately 8 o'clock in the morning, Mount Pelée unleashed one of the most violent eruptions in recorded history. Without warning, a massive explosion tore through the mountain's side. What followed was not lava, but a deadly blast known as a pyroclastic surge. A fast-moving cloud of superheated gas, ash, and rock that raced down the slope at speeds faster than any human could outrun. This surge reached St. Pierre in less than 1 minute. The wave of heat was so intense that it ignited everything in its path: wood, clothing, and even people. Buildings were flattened or caught fire instantly. Ships anchored in the harbor burst into flames. Stone structures crumbled, glass shattered. The surge didn't just burn, it crushed and suffocated. Those who tried to flee had no chance. The temperature of the cloud was high enough to kill instantly, and the pressure destroyed lungs before people could take their final breath. Within minutes, the entire city was in ruins. Fires broke out across neighborhoods, turning St. Pierre into a smoking wasteland. The eruption didn't stop there. It continued to release ash and gas into the atmosphere, covering the surrounding landscape in darkness. For those observing from other parts of Martinique, the view was horrifying. A giant black column rising from the volcano, shaped like a mushroom cloud, glowing with lightning and flame. In the days that followed, rescue teams arrived to search the wreckage. What they found was devastating. Of the nearly 30,000 people who had been in St. Pierre that morning, almost none had survived. The city, once called the Paris of the Caribbean, had been completely erased in less than 5 minutes. The only known survivor from the city center was a man named Ludger Silbaris, a prisoner locked inside a small windowless jail cell that protected him from the heat and ash. His survival was considered a miracle. Mount Pelée's eruption shocked the world. It was not just a natural disaster, it was a warning about how little was understood about volcanoes at the time. The pyroclastic surge, a type of eruption rarely documented before, introduced a new level of destruction that scientists would study for decades to come. But for Martinique, the loss was immediate and unforgettable. One of its most important cities had vanished, and the scars left behind would never fully heal. After the destruction of St. Pierre, the island of Martinique was left in mourning. Entire families were gone, and the cultural heart of the island had been wiped out. Survivors from nearby villages struggled to process what had happened. Many had lost loved ones, homes, and livelihoods in an instant. The scale of the disaster was hard to grasp, even for those who had seen the ash and flames with their own eyes. News of the eruption reached the rest of the world quickly. In France and across Europe, headlines described the death of a city. Relief efforts began almost immediately. Ships arrived carrying supplies, doctors, and volunteers. But there was little that could be done. The area around St. Pierre was still dangerous. Ash covered the ground like snow. Buildings were unrecognizable, and fires smoldered for days. It would take weeks to recover the dead, and in many cases, nothing remained to bury. One of the most notable outcomes of the disaster was the change it brought to scientific understanding. Geologists from different countries came to study the eruption and its aftermath. Mount Pelée became a key case for the study of pyroclastic flows, which had previously been misunderstood. Researchers also noted the strange weather that followed the eruption, including red sunsets and ash clouds that drifted across the Atlantic. The volcano's behavior helped shape modern methods of monitoring and predicting eruptions. Despite this progress, Mount Pelée remained active. Smaller eruptions occurred in the years that followed, including one in the year 1905. These events slowed the rebuilding process. Although a new settlement eventually formed near the ruins, Saint-Pierre never regained its former importance. The capital of Martinique was moved to Fort-de-France, where most government and trade activities remain today. The story of Saint-Pierre and Mount Pelée lives on through memorials, museums, and local storytelling. The preserved remains of the city still attract visitors who want to understand what happened on that terrible morning. The old prison cell where Ludger Silbarus survived can still be seen. His survival was used in traveling exhibitions, and he later joined a circus in the United States, where he shared his story. The eruption of May 8, 1902, stands as one of the deadliest volcanic events in history. It serves as a reminder of nature's unpredictable power and the importance of preparation. While Saint-Pierre could not have been saved with the knowledge of the time, the lessons learned from its loss have helped protect other communities around the world. Today, Mount Pelée is closely monitored, and the tragedy that once struck the island remains a powerful part of Martinique's identity. Mount Redoubt, a towering stratovolcano in southern Alaska, stood silent for over 20 years before showing signs of an awakening in late 1989. Nestled within the Aleutian Range, this massive volcano had a history of eruptions, but its long dormancy had lulled many into a sense of security. However, beneath its seemingly tranquil exterior, forces were building that would soon make headlines across the globe. In the months leading up to the eruption, subtle shifts in the volcano's behavior caught the attention of scientists. Small but persistent earthquakes rippled through the ground, a telltale sign of magma movement deep within the earth. The frequency and intensity of these tremors gradually increased, hinting that Mount Redoubt was preparing for something significant. Steam emissions from the summit vents became more frequent, and the surrounding glaciers began to show signs of melting. The United States Geological Survey, USGS, closely monitored these changes, piecing together the clues of the impending eruption. At that time, volcanic monitoring technology was not as advanced as it is today. Instruments like seismometers and tilt meters provided critical data, but they were limited in their ability to predict the exact timing or magnitude of an eruption. This uncertainty left scientists and local residents alike in a state of constant vigilance, waiting for the inevitable. The region around Mount Redoubt, known for its rugged beauty, was home to scattered communities, small towns, and vital infrastructure. The nearby Drift River Terminal, a facility used for storing and shipping crude oil, was a major concern. Its proximity to the volcano made it highly vulnerable to the potential hazards of an eruption, such as ashfall, lahars, and pyroclastic flows. Preparations to mitigate risks were underway, but no one could predict the scale of what was to come. By early December of 1989, the seismic activity had reached a fever pitch. Earthquakes were now occurring in rapid succession, and steam plumes rose ominously from the summit. The USGS issued alerts warning of a likely eruption. Local authorities coordinated emergency plans, and residents prepared for the worst, stocking up on supplies and making evacuation plans. Despite these efforts, the sense of unease lingered. As the days ticked by, tension grew. The world turned its eyes to Alaska, captivated by the dramatic buildup of one of nature's most powerful forces. Scientists worked tirelessly to decipher the signals coming from Mount Redoubt, knowing they were witnessing a prelude to a significant geological event. The stage was set, and the volcano's long slumber was about to end in spectacular fashion. On December 14, 1989, Mount Redoubt ended its years of dormancy with a sudden and dramatic eruption. It began with a powerful explosion that sent a towering column of ash and gas spiraling nearly 10 miles into the atmosphere. This was the first in a series of eruptions that would last for months, each more unpredictable than the last. The initial eruption coated the nearby landscape in a thick layer of volcanic ash, turning daylight into a dim, gray haze. For the people living in the surrounding areas, this marked the start of a challenging and chaotic period. The ash cloud, propelled by strong winds, spread far beyond the volcano, affecting communities hundreds of miles away. Air travel, a lifeline in Alaska's vast and often remote regions, came to a standstill. Anchorage, the state's largest city, saw its airport operations severely disrupted as ash particles posed a serious threat to aircraft engines. Flights were grounded or rerouted, and travelers were left stranded. Pilots navigating the airspace faced the daunting task of avoiding the massive ash plume, which could cause catastrophic engine failure if encountered. The eruption also unleashed another dangerous phenomenon, lahars. These fast-moving torrents of volcanic mud and debris formed as the heat from this eruption melted the glaciers and snow on Mount Redoubt's summit. The lahars surged down the mountain's flanks, carving paths of destruction through valleys and waterways. One of the most notable impacts was at the Drift River terminal, where crude oil tanks were directly in the path of these devastating flows. Emergency crews worked around the clock to protect the facility, building berms and pumping out oil to prevent a potential environmental disaster. For weeks, Mount Redoubt continued to erupt intermittently, with each event bringing new challenges. Volcanologists documented pyroclastic flows, searing avalanches of hot gas and rock that raced down the mountain at incredible speeds, obliterating everything in their path. These flows not only reshaped the terrain, but also created significant hazards for those attempting to study or manage the eruption's effects. The ongoing eruption forced many residents to evacuate their homes, leaving behind their belongings and livelihoods. Schools and businesses closed, and communities struggled to adapt to the new reality of living under the shadow of an active volcano. Emergency shelters were set up, and local governments coordinated efforts to distribute clean water and medical supplies to those in need. The ashfall contaminated water supplies, clogged machinery, and created respiratory issues, particularly for children, the elderly, and those with pre-existing health conditions. Scientists working on the ground faced immense challenges as well. The conditions were harsh, with ashfall reducing visibility to mere feet and coating their equipment in fine abrasive dust. Despite these difficulties, their efforts to monitor and study Mount Redoubt provided critical information that helped guide emergency responses and protect lives. As the eruptions continued into early 1990, it became clear that this was no ordinary volcanic event. The sheer scale and intensity of Mount Redoubt's activity captured the world's attention, highlighting both the destructive power of nature and the resilience of the communities affected. As Mount Redoubt's eruptions intensified in early 1990, the volcano unleashed some of its most powerful and dramatic displays. The ash plumes grew larger, frequently reaching altitudes of over 40,000 feet, and disrupted air travel, not just within Alaska, but across significant portions of North America. The fine volcanic ash particles carried by the wind spread as far as parts of the lower 48 states and Canada, creating a widespread environmental and logistical challenge. One of the most significant hazards during this period was the impact on aviation. Volcanic ash is notorious for its ability to cause severe damage to aircraft engines, potentially leading to in-flight engine failure. A particularly harrowing incident occurred in December 1989 when a KLM Royal Dutch Airlines flight encountered the ash cloud. The Boeing 747's engines all failed mid-flight, leaving the massive jetliner in a dangerous glide. Miraculously, after multiple attempts, the pilots managed to restart the engines, narrowly avoiding disaster. This close call underscored the critical need for real-time volcanic monitoring and prompted aviation authorities to establish better protocols for volcanic ash avoidance. Back on the ground, the lahars continued to wreak havoc. As the eruptions melted the extensive glacial ice atop Mount Redoubt, these destructive mudflows grew in size and frequency, cutting through valleys and river systems. They repeatedly threatened infrastructure like the Drift River oil terminal, where protective measures were constantly tested. Engineers and emergency crews worked tirelessly to reinforce barriers and divert flows, preventing catastrophic damage to the facility and potential oil spills into nearby ecosystems. The Drift River evacuation and safeguarding efforts became a symbol of the complex interplay between human activity and natural disasters in Alaska's rugged environment. The surrounding communities faced ongoing hardships as the eruptions dragged on. Ashfall remained a persistent problem, blanketing towns and causing widespread damage to machinery, vehicles, and buildings. The abrasive ash clogged air filters, corroded surfaces, and created long-term maintenance challenges for equipment critical to daily life in Alaska's remote regions. Residents had to wear masks and goggles to protect themselves from the health risks posed by the fine particles, which could irritate the lungs and eyes. Roads became treacherous as the ash mixed with snow and ice, creating slippery and unpredictable surfaces. In addition to the physical dangers, the eruptions brought significant psychological and economic stress. Families were displaced from their homes for extended periods, businesses suffered losses, and the cost of disaster response and recovery mounted. For many, the constant uncertainty of when the eruptions might cease added to the emotional toll. Local officials worked alongside federal agencies to coordinate relief efforts, ensuring that food, water, and medical supplies reach those most in need. Community resilience was put to the test as people banded together to support one another through the crisis. Meanwhile, scientists continued their meticulous monitoring of Mount Redoubt's activity. Advances in technology allowed volcanologists to gather data in ways that had never been possible during previous eruptions. Instruments measured everything from seismic activity and gas emissions to the rate at which glaciers were melting. The findings not only helped to inform immediate response strategies, but also contributed to the broader understanding of how stratovolcanoes like Mount Redoubt behave. This eruption became a landmark case study in volcanology, with lessons that would inform future monitoring and preparedness efforts around the world. As Mount Redoubt continued to erupt well into the spring of 1990, it became increasingly clear that this event was reshaping both the physical landscape and the lives of those who called the region home. The combination of natural destruction and human determination would leave a lasting legacy in Alaska's history. As the eruptions of Mount Redoubt gradually waned in the summer of 1990, the immediate crisis transitioned into a period of recovery and reflection. The region, once blanketed in layers of ash and scarred by the powerful lahars, began the slow process of healing. For the people who lived through this event, the eruption left not just physical marks on the landscape, but also lasting impacts on their communities, industries, and scientific understanding of volcanoes. In the aftermath, cleanup efforts became a monumental task. Entire towns had to deal with the thick layers of ash that coated homes, streets, and public spaces. Removing the ash required careful coordination as it posed significant risks to both machinery and human health. Crews used heavy equipment to scrape it away while individuals worked tirelessly to restore their properties. Water systems clogged with ash needed extensive repairs, and local governments faced the challenge of funding these efforts while ensuring the safety and well-being of their residents. The long-term environmental effects of the eruption were equally profound. The ash deposits enriched the soil in some areas, boosting plant growth in the years that followed, but they also caused significant disruption to local ecosystems. Rivers and streams choked with volcanic material, altered their courses, and disrupted fish habitats, impacting the vital salmon populations that so many Alaskans relied on for food and income. Wildlife, too, was forced to adapt to the dramatically changed landscape, and some species faced increased challenges in the immediate years after the eruption. Economically, the eruption's consequences were wide-reaching. The aviation and oil industries, both crucial to Alaska's economy, bore the brunt of the disaster. The grounding of flights during the peak of the eruptions caused financial losses for airlines and disrupted travel for thousands of passengers. The Drift River oil terminal, though saved from catastrophic destruction, required extensive repairs and operational adjustments. For many businesses in affected areas, the cost of recovery proved a significant burden. Despite the challenges, the eruption also brought important advancements in volcanic science and disaster preparedness. The data collected during Mount Redoubt's eruption became a cornerstone for understanding how volcanoes interact with glaciers, how ash plumes affect aviation, and how lahars behave in rugged terrains. This information informed future disaster response strategies, not just in Alaska, but globally, as scientists and emergency planners applied these lessons to other volcanic regions. The eruption of Mount Redoubt also highlighted the resilience of Alaskan communities. Faced with one of the most significant volcanic events of the 20th century, people came together to rebuild and support one another. From Anchorage to the small towns near the volcano's base, stories of neighborly assistance and determination emerge as reminders of the human spirit's ability to endure even the most daunting challenges. By the end of 1990, Mount Redoubt had largely quieted, leaving behind a transformed landscape and a wealth of scientific knowledge. While the volcano remains active and continues to be monitored to this day, the events of 1989 and 1990 stand as a testament to the incredible power of nature and the resilience of those who face its wrath. The legacy of Mount Redoubt's eruption lives on, not just in the memories of those who experienced it, but in the advancements it spurred in science, safety, and preparedness. It remains a potent reminder of the unpredictable and awe-inspiring forces that shape our planet, challenging us to learn, adapt, and respect the natural world. Yellowstone National Park is home to one of the most dangerous and awe-inspiring natural wonders in the world, a supervolcano. It's not just any volcano, it's a massive geological feature sitting quietly under the surface, with the potential to cause an event so catastrophic it could change life as we know it. This supervolcano has been dormant for thousands of years, but beneath the surface there's constant movement. Magma is churning, pressures are building, and every now and then, scientists see signs that something is brewing. While we don't know exactly when it will erupt, we know that it's still an active and volatile system, and experts warn that we are overdue for an eruption. If Yellowstone were to erupt tomorrow, the immediate effects would be so intense and destructive, it would feel like a disaster movie come to life. The eruption would likely begin with a massive earthquake as magma rises toward the surface, shaking the land and sending a tremor through the region. That earthquake would be followed by an eruption of unimaginable power. The skies would quickly darken as a massive ash cloud began to billow into the atmosphere. This cloud could stretch thousands of miles, covering much of the United States and beyond. The ash would block out sunlight, creating an eerie, apocalyptic atmosphere that would make it seem like day had turned to night. The ash fallout would have immediate and devastating consequences for the environment and human life. Cities like Denver, Salt Lake City, and even further parts of the country would be buried under layers of ash, disrupting air traffic, causing buildings to collapse under the weight, and making it incredibly dangerous to breathe. Respiratory problems would become widespread as fine ash particles filled the air, while the agriculture sector would face total destruction. Crops would be destroyed and livestock would perish, leading to food shortages and economic collapse. And at the same time, pyroclastic flows, which are fast-moving superheated gas and rock avalanches, would begin to flow out of the volcano at deadly speeds. These flows would travel for miles, scorching everything in their path. The heat would be so intense that it could melt the asphalt on roads, turning even the most ordinary routes into death traps for anyone trying to escape. As the flows move, toxic gases would be released into the air, further polluting the environment and making survival even more difficult. These pyroclastic flows would continue to spread, decimating the landscape and causing even more destruction. Imagine seeing an entire region being transformed into a hellish landscape, a world where everything is set on fire and nothing survives. The eruption's effects wouldn't be limited to just the areas surrounding Yellowstone. One of the most alarming impacts would be the potential for global cooling. The vast amount of ash and sulfuric gases released into the atmosphere would block out sunlight for months, or possibly even years. This could lead to what scientists call a volcanic winter. Temperatures around the world would plummet and the weather patterns would be completely disrupted. This global cooling would have a disastrous effect on crops, leading to widespread famine and food shortages. The Earth's climate would struggle to recover, and the ripple effects would be felt in nearly every country. The economic impact would be almost beyond comprehension. The global economy relies on trade, and with airports closed, roads destroyed, and communication lines down, the movement of goods would be severely disrupted, markets would crash, and countries would face severe financial strain. Many nations would find themselves unable to deal with the economic fallout, and some might even face bankruptcy. The agricultural collapse would be devastating not just in the United States, but around the world. The financial losses would be astronomical, and rebuilding would take decades, if not longer. This is the kind of destruction that scientists have been warning about for years. While it's not certain when or if this eruption will occur, it's clear that the supervolcano beneath Yellowstone remains active. And when it finally erupts, the consequences could be far-reaching and catastrophic. The world as we know it could be completely changed by a single event. This is why it's so important to understand what Yellowstone could do and to start thinking about how we can prepare for something that, though unlikely to happen tomorrow, is still a real and possible threat. Now that we understand just how destructive a Yellowstone eruption would be, let's dig deeper into the scientific side of it. What makes this supervolcano so dangerous, and why is it considered such a threat? To start, Yellowstone is not a single volcano, but a giant volcanic system that sits on top of a hotspot in the Earth's crust. This hotspot allows magma from deep within the Earth to rise toward the surface, and over millions of years, it has created what we now know as the Yellowstone caldera, which is essentially the largest active volcanic system in North America. The key to understanding the scale of a potential eruption lies in its geological history. Yellowstone has erupted 3 times in the past 2.1 million years, with each eruption being more powerful than the last. The most recent eruption occurred around 640,000 years ago, and it was so massive that it blanketed much of the western United States in ash. That eruption was what scientists refer to as a super eruption, capable of unleashing energy equivalent to thousands of atomic bombs going off at once. While the eruptions weren't constant, the caldera has shown ongoing signs of activity, and that's what makes Yellowstone so volatile. One of the most unsettling things about Yellowstone is that scientists have found evidence of continuous seismic activity, which means that the ground is constantly shifting. This ongoing ground deformation indicates that magma is still moving beneath the surface, causing pressure to build. The U.S. Geological Survey and other scientific organizations closely monitor these changes, watching for any signs of unusual volcanic activity. Despite this constant monitoring, however, we can't predict exactly when an eruption will occur. It could happen tomorrow, next year, or even 1,000 years from now, but what is certain is that Yellowstone is still active, and one day it could erupt once again. What would an eruption like this look like from a geological standpoint? The magma chamber beneath Yellowstone contains an enormous amount of magma, much more than typical volcanoes. If this magma were to rise rapidly to the surface, it would cause the ground to crack open. The immediate eruption would start with a violent explosion, sending a colossal amount of ash and gas into the air, potentially reaching altitudes that could affect the global atmosphere. At the same time, lava would pour from the caldera, creating rivers of molten rock that would flow for miles, scorching everything in their path. The sheer volume of material ejected during a Yellowstone eruption is mind-boggling. It's believed that the eruption could send hundreds of cubic kilometers of ash, lava, and volcanic gases into the atmosphere. To give you an idea of how massive this would be, a typical volcanic eruption releases a few million cubic meters of magma, but a Yellowstone super eruption could release more than 1,000 times that amount. This is what makes Yellowstone such a dangerous and unpredictable force in nature. The sheer scale of its potential eruption could dwarf anything we've ever seen in recorded history. In addition to the direct effects of an eruption, another issue would be the ongoing environmental changes that would follow. The ash alone would be enough to alter weather patterns for years. The global cooling effect, often referred to as volcanic winter, could cause temperatures to drop significantly, leading to frost and snow even in the middle of summer. This kind of climate change would lead to massive disruptions in the natural world. Ecosystems would be severely impacted, with plant and animal life struggling to survive in an altered environment. The global food supply would be in danger as crops would fail due to the lack of sunlight and sudden drops in temperature. This environmental shift would not only impact agriculture but also human health. The ash in the air would make it difficult to breathe, and the toxic gases like sulfur dioxide could cause widespread respiratory problems. Even if people managed to escape the immediate impact zone, the effects of the eruption would continue to affect them no matter where they went. These gases could cause acid rain, poisoning bodies of water, and further destroying the landscape. Yellowstone's eruption would also put major stress on the global economy. Countries would face immense financial difficulties as they tried to deal with the aftermath. The eruption would likely take out entire regions of infrastructure, including roads, bridges, and electrical grids. This would make it impossible for many areas to function normally. Airports would be shut down, making it nearly impossible to fly anywhere. Cities would be cut off, and it would be difficult to deliver aid to affected areas. Global supply chains would collapse, and businesses would struggle to recover, leading to widespread economic hardship. This kind of catastrophic event could take years to recover from, and some areas might never fully return to normal. The risks associated with Yellowstone are not just theoretical. They are very real, and it's something we must prepare for. While scientists continue to monitor the area, there's no way to predict exactly when the eruption might occur. What we do know is that the signs are there, and we need to be aware of what could happen if that time comes. Being prepared means understanding the scale of the threat, the environmental impact, and the potential consequences of such a devastating event. As we continue to explore the potential effects of a Yellowstone eruption, it's important to focus on the immediate aftermath and the challenges humanity would face in the wake of such an event. What happens after the eruption? What would the world look like, and how would society respond to this unprecedented disaster? First, we need to understand how the landscape itself would be transformed. The eruption would be so catastrophic that the area around Yellowstone would be left nearly unrecognizable. A massive crater would form where the caldera used to be, and the ground itself would collapse, creating a huge depression in the Earth's crust. This massive void would change the geography of the region, and rivers, lakes, and forests would be forever altered. The eruption would not just affect Yellowstone National Park, it would change the entire surrounding area. possibly affecting as much as half of the United States. One of the most immediate threats would be the ash fallout. This ash would blanket the landscape for hundreds of miles, severely impacting infrastructure and making everyday life nearly impossible. Imagine entire cities buried under inches or even feet of ash. Roads would be impassable, and buildings would collapse under the weight. Ash would clog machinery, including cars and aircraft, making transportation nearly impossible. It would even be dangerous to breathe, as the fine particles would cause severe respiratory issues for anyone caught in the fallout. For those who survived the initial explosion, they would now be facing an environment that is toxic and suffocating. One of the greatest challenges would be the massive number of displaced people. Cities and towns across the affected regions would be evacuated, as the ash would make it impossible to live or work in those areas. This could lead to a mass exodus, with millions of people trying to find safety in other regions. However, with transportation systems destroyed and the roads blocked, movement would be extremely difficult. Temporary shelters would be set up in less affected areas, but these would quickly become overwhelmed, leading to overcrowded conditions and shortages of food, water, and medical supplies. Humanitarian aid would be essential, but getting help to those who need it would be incredibly challenging due to the disrupted infrastructure. The economic impact of the eruption would also be catastrophic. Trade routes, both domestic and international, would be completely disrupted. The ash cloud would block out sunlight, causing crop failures around the world. This would lead to widespread food shortages, especially in countries that rely on American exports. Global economies would be plunged into turmoil, and many countries could face a complete collapse. The damage to the environment, infrastructure, and economy would take years, even decades, to recover from. The climate would change dramatically as well. With the massive amounts of ash and sulfur dioxide released into the atmosphere, a phenomenon known as volcanic winter would take hold. This would cause temperatures to drop significantly around the world. For a time, the Earth's climate could cool by several degrees, which would have devastating consequences for agriculture. Short growing seasons, colder temperatures, and altered precipitation patterns would cause crop failures and make it harder to produce enough food to feed the global population. The cooling effect could last for months or even years, making it difficult for humans to adapt and survive. As the world deals with these dramatic environmental and societal changes, governments and organizations would be scrambling to respond. Emergency services would be overwhelmed, and it's uncertain whether they would be able to reach all affected areas. Even if rescue and relief efforts were successful in some regions, many areas would be left to fend for themselves. In some places, emergency crews might be unable to reach those in need due to blocked roads, destroyed buildings, or hazardous conditions. The sheer scale of the eruption would make it incredibly difficult to mount an organized response, and without communication lines, coordination would be nearly impossible. In the wake of such destruction, society would have to adjust to a new normal. With the economy shattered and the environment severely impacted, life as we know it would fundamentally change. The social fabric would be tested as people scramble to survive, and communities would need to come together to rebuild what was lost. Governments would face enormous challenges in managing the recovery process. Resources would be scarce, and the long-term environmental damage could affect generations to come. What's clear is that the eruption of Yellowstone would not just be a natural disaster, it would be a global crisis that would reshape the course of human history. What would be the psychological and emotional toll on people? It's hard to imagine the level of trauma that would follow such an event. The loss of loved ones, homes, and entire communities would be heartbreaking. People would be forced to confront not only the immediate devastation, but also the long-term effects of living in a world drastically changed. The constant uncertainty about when or if life will ever return to normal would create widespread anxiety and stress. It's difficult to say how people would cope with the aftermath of something so overwhelming, but the survival instinct would likely push many to keep going. Even in the face of the most dire circumstances, the aftermath of a Yellowstone eruption would be far more than just a natural disaster. It would be an event of such immense scale that it would challenge the very survival of humanity. From the immediate environmental destruction to the long-term societal and economic consequences, the world would be irrevocably changed. As we reach the final part of this exploration into the hypothetical eruption of Yellowstone, it's important to reflect on how the world might eventually recover. Although the scale of the disaster would be unprecedented, humanity has always shown remarkable resilience in the face of catastrophe. In this part, we'll look at the potential paths to recovery and what steps would need to be taken to adapt to a drastically changed world. And one of the most pressing challenges would be rebuilding the global infrastructure. After the eruption, communication systems would be down, electricity grids would be destroyed, and many roads would be impassable due to ash, lava, and the collapse of structures. The immediate aftermath would be chaotic, with governments and organizations trying to re-establish order and get aid to the people who need it most. While recovery would be slow, it's possible that technological advancements could help speed up the process. In the years following the eruption, nations might work together to rebuild their infrastructures, focusing on alternative energy sources and more resilient designs for homes and cities. The goal would be to create a more sustainable and adaptable society that could withstand future natural disasters. The environmental recovery would be just as crucial but far more difficult. The volcanic winter caused by the eruption would cause crops to fail globally, leading to food shortages. In the months and years following the eruption, scientists would be studying the effects on the atmosphere, climate, and ecosystems. It's likely that agriculture would need to be radically transformed. Traditional farming methods might be replaced with new techniques that are more resistant to the harsh conditions created by the eruption. Vertical farming, genetically modified crops, and innovations in food production could become critical to feeding a world that is struggling with crop failures. Additionally, efforts to restore ecosystems damaged by ash and pyroclastic flows would be essential, but the recovery of forests, rivers, and wildlife could take decades, even centuries. Another area that would need significant attention is the psychological impact of such a disaster. The eruption of Yellowstone would not just be a physical disaster, but a psychological one as well. People around the world would be dealing with grief, trauma, and fear, as entire communities and cultures might be wiped out. In the aftermath, mental health support would be essential to help individuals and families cope with the emotional toll of the disaster. The loss of homes, loved ones, and the familiar world would require extensive counseling, therapy, and community rebuilding. Over time, people would need to find hope and purpose in the midst of devastation, and mental health organizations would be on the front lines, helping people adjust to the new reality. The global economy would eventually need to stabilize as well, although this would take time. The eruption would disrupt global trade, cause widespread unemployment, and leave economies in ruins. But history has shown that economies can recover, albeit slowly. A focus on sustainable development and rebuilding industries would be key to long-term recovery. New markets would likely emerge, such as those focused on clean energy and technologies to mitigate future disasters. Countries that are able to adapt to the new environmental conditions and work together in rebuilding global supply chains may be able to bounce back more quickly. However, the global community would need to reimagine the way we operate as a species, moving away from reliance on fossil fuels, for example, and focus on creating systems that can withstand future challenges. In the face of all these challenges, one of the greatest opportunities for recovery would lie in international cooperation. The eruption of Yellowstone would affect the entire globe, and no single nation would be able to recover alone. In fact, the scale of the disaster would make global cooperation essential. Countries would need to share resources, information, and expertise to rebuild and adapt to the new environmental realities. While the eruption could strain international relationships, it could also serve as a wake-up call, pushing nations to collaborate in ways they never have before. Together, we would have to tackle the issue of climate change head-on, learn from past mistakes, and build a future that is more resilient to natural disasters. As humanity slowly adapts to life in a post-Yellowstone world, one thing would be certain: the eruption would leave an indelible mark on our collective consciousness. We would likely come to view the world differently, more fragile, more interconnected, and more in need of careful stewardship. The disaster would remind us of how vulnerable we are to the forces of nature, but also of our incredible ability to rebuild and rise from the ashes. In the end, the recovery from a Yellowstone eruption would be one of the greatest challenges humanity has ever faced. It would test our survival instincts, our ability to adapt, and our willingness to come together as a global community. The consequences of such an event would ripple through history for generations to come, but with perseverance and innovation, life could eventually return to something resembling normalcy. What's clear is that the world would never be the same again, and humanity would have to learn from this catastrophic event to build a more sustainable, resilient future for ourselves and future generations. Thanks for sticking with me through this wild journey into the world of Yellowstone and what would happen if it erupted tomorrow. I hope this scenario has sparked your curiosity about the potential impacts of natural disasters. Let me know in the comments how you would prepare for such an event. And as always, don't forget to check out my other videos on natural disasters and emergency preparedness. You never know what might be next.